we're going to talk now about this new change in head maps and why we're doing it. It's important. So here's the old format that you've been using on the left. And we had very good reasons for using this format and not going to topos. And we're not abandoning it because we still think we think it's a superior way to look at it. But there's this constant, eye candy is really big, whether you're a medical doctor or you're a fashion specialist. And everybody is seduced by it. And the topo maps have always been seductive and suggested that somehow there is more sophistication because your graphs or your presentation's more sophisticated. And of course, that's why people dress sophisticated, so they can make you think how sophisticated they are, but then you ask them, and talk in sophisticated terms, but then you ask them for details and they don't have them. So this is common in every social environment, and it's an ancient issue. But we wanted to give everybody the new eye candy, and we're doing it just to keep up with the Joneses, admittedly, and in some ways ahead of the Joneses. But but also your clients like the eye candy. It makes them feel really good. So, and they may see another mapping system and go like, well, how come your eye candy's not as good as their eye candy? They must be more sophisticated. So we're kind of an end run around that too. But the great thing about the old format, it shows you exactly what's happening at each location. But this looks really nice on the right, sophisticated, and it tells you what's going on, but in a different way. So that's what's going on. Okay, so real rationale for all the format change. Okay, the original QEG formats were designed for research, not for clinical work. They were never changed or adapted for clinical work, and the people who were in control of them and changed them were researchers. If you go and check them all out, they were all research people. They weren't clinicians like you. They didn't have clinical degrees. They were all mathematicians or chemistry majors or engineers or something, but they were not in the trenches clinicians doing neurofeedback. So that's why all these map systems are so complicated and so overwhelming for most clinicians when they get in them. And those formats included all possible data that they could think of. So any variable that they could think of, they put in these map systems because they're doing research, and that makes perfect sense for research. But for clinical work, it doesn't make perfect research sense. You're not doing research, you're doing clinical work. You're applying the research. So you want to keep your clinical measures down to things that you know are relevant and pertinent to the clinical environment, that correlate with other measures that you're using, and that don't crowd or confuse things. And that wasn't happening in the map systems. They were just getting more and more complicated. And the gatekeeping got more and more stringent as the bar got higher and higher, and you had to have more and more degrees and more training just to be able to use a map system, which is ridiculous. So why bother even having neurofeedback if the gatekeeping is so severe that only a tiny portion of the population, the elite of the elite, is qualified to do it? And that's one of my objections to QEG certification too. QEG certification is part of BCI certification. I do the web course. It's in the Blueprint of Knowledge, and we discuss it in there. And you have to know it in order to do neurofeedback. You don't have to use it. We can't make you, but we want you to. So I think the QEG certification is just a gimmick, another way to gatekeep, make money, et cetera, but I'm always the outlier in this, and people don't like me saying those things. And so, but I have a right to disagree. I have the degrees and the experience, so that's my disagreement. So not all the data had clear clinical correlations. We don't really know what delta and theta asymmetry is. And I was hesitant to even put that in, but I thought, well, people are going to just go crazy. Like, well, how come I can't see the other stuff? And maybe there's something I'm missing. So we put delta and theta asymmetry in there because something may have come up and it's a broad measure. There's a lot of other detailed measures we didn't put in. Um, uh, and so all the data is not useful in a clinical setting. What's what's and dominant frequency? What's slow delta mean? You find research on that for me. I'd love to see it. I'm not finding it. Um, and so all of this extra data, endless pages, and confusing stuff uh, really complicates the training usage. And it's intimidating to clinicians that there's so much to learn. They're like, well, why am I even bothering to do this? I'm not a neurologist. I'm not a mathematician. I don't have a degree in statistics. Well, that's ridiculous. Medical doctors aren't either, and they don't either, and they use MRI. And they don't give you your MRI maps. They say to you, well, the MRI shows this and this and this. They might give you the report that has a paragraph on what the findings were. But we have clinicians showing their clients the whole darn brain map, and you have all these engineers thinking they know everything and God too, and they're going to look at it and say like, "Oh well, I can do this. I'm an engineer, and I can see this." And let me tell you, and how did you get that and that? And suddenly, the big guys trying to push around, the clinicians. Like, wait a second, you don't have a degree in electrophysiology or any of this. What gives you the right to do that? And I'm sure they would do that to the doctors too. If the doctors showed them the MRI, well, how did you statistically define these spaces on the MRI? What are the correlation methods? It's like, hey, this has been reviewed. Go someplace else, please. So it's intimidating the clinicians. It's intimidating the clients. It complicates training usage. It results in gatekeeping, which happens in every field. And really causes a lot of problems in a lot of fields, particularly these days. It complicates interpretation. Well, if you've got thousands and thousands of variables, how are you going to interpret that? You can't. It's a joke. Even if you're an expert in brain maps, you can't. There's no human being who can manipulate all that data in the brain and come to a firm conclusion. And somehow there's this myth out there that is the case. And it's not that. It just doesn't exist. We all need tools to simplify what we're seeing, but we have to build those tools upon research and experience. And sometimes they're very effective and sometimes they're not so effective. I mean, we ended up with training efficiency on our trend screens, which is a pretty good metric, but people misinterpreted it or wanted it to mean something it didn't mean. And we really didn't know just how efficient it would be until we ran it for a while and looked at the data. We know it would be useful. And so we spend a lot of time explaining to people that is not your number one number. You want to look at asymmetry and activation, not training efficiency. It's a useful metric, but it's not the central metric. Again, it's easy for people to misinterpret what's important. So that's part of how important it is to design things so that it's easy for you to make sense of it, interpret it. We don't want to complicate interpretation. But we have now decades of investigation, and we can provide guidelines for simplifying. We have been doing this for 25 years since the first database was commercially released in 1996, and that was NX-Link out of New York Medical University. And Dave Cantor and Bob Thatcher were key players in there when they worked with E. Roy John. And that's why I was so complimented when Dave asked me to write a chapter on QEEG. That said to me, he says, well, you seem to get this pretty well compared to most people. And that's one of the reasons I'm doing this. So there's decades of guidelines now. We can pick and choose what we know for sure is useful clinically for neurofeedback, not for research, not for medical diagnosis, but for purposes of doing neurofeedback. So that's what it's been reduced for. So what are the benefits of our new format? Our new format simplifies interpretation. It reduces clutter. There's a lot of stuff in the present head map that's, again, like I said, we don't really have clear research on the implications. We're happy if you want to do it, but We don't have the time. We don't have to add grad students and big grants. Um, it's getting people to focus on what we know is the relevant data from a clinical perspective, from decades of running stats and clinical observation and lunch and learns and talking together with these hundreds of clinics. We know, got a pretty good idea what the relevant data. This new map will enhance ease and speed of interpretation for you, so you can look at it and get a much faster at a glance idea. Now, you can always switch to the old view if you want to drill down now. It makes the head maps more accessible. When you show it to clients, they're seeing something they're more useful to seeing bars and histograms, and it's just more friendly to them. And there are also people using brain maps out there, like some chiropractors and other people for head trauma and so forth. And it makes it easier for them to make sense of it and show it with their clients. So there are people with other professions besides counseling and psychology who are using neurofeedback. And that's understood under BCIA certification. And so we want to make it more accessible to them too. And I can't tell you how much over the last decade I hear complaints from the other professionals saying, why is this such a complicated mess? There's no other field that has such a mess for maps and information for clients and professionals. And the reason is because of the research elite who controlled what we looked at for so many years in neurofeedback. So now it's easier to share with clients and other professionals. I'm telling you, though, the psychiatrists and the doctors will love you much more when they see a map that's easier to make sense of. It provides more clinical control over presentation. You don't have the engineers in there, trying to second guess you on everything on the map system. And it's more attractive and has a more familiar format. So with that in mind, let's look at it. And take a look at it. Here is somebody, I put this up on standard deviation to make it more accentuated, but you can see the patterns follow exactly the patterns in here. Now, of course, ours looks different from everybody. Of course, we're always the outlier, right? Because we're always trying to stay with the data and do it from what we say and see as clinically valuable. But P3 and P4 and O1, O2 are fairly limited in their range and their effect. Now, with the other topos, they interpolate everything in between. And that can cause, from a pattern perspective, as a human being, that can cause misinterpretation and misjudgments. So we're narrowing the interpolation areas to try and keep that from happening. Now, we're going to watch how everybody deals with it. If they're good with it, if we get good rationales, good complaint, any research to contradict what we're doing, obviously we're going to change. But based on our feedback, the beta users, the research that we see and read, this is a really valid and efficient way of presenting them. So we have nice heads, lots of good eye candy for the other professionals who love it. And then we have really kind of rigid interpretation of the locations. You see, this is yellow here. It doesn't spill way over. We can see with the gray is here. These areas are fairly well defined of where in the brain is the problem. See the blue here on the side and so forth. Now, I'm just going to compare this to NeuroGuide, not for any reason. If you're going to do research, I'm telling you NeuroGuide is the thing to do research with, because it is it was done at New York Medical University. It's got a high pedigree in research. It's already accepted in research. And to tell you the truth, most people in neuroimaging don't like QEEG and have a very low opinion of the databases and their validity and reliability. You read the research and they're going all the way back to the neurology people complaining about it in the mid-90s. They're not happy about it. And I always tell everybody, if you want to do research, use the raw data and use standard statistics. Don't use a database, because it'll just be easier to get it published. Most the review journals just are not that familiar. I mean, Thatcher's database is very valid and very reliable, and it's got great research. And if you're doing research, it should be accepted in all the journals. But they still give people a hard time about it, which is ridiculous. At any rate, so here's Thatcher's database, and here's ours. Again, ours is developed for clinical purposes. We even alter the standard deviation coloring so that it agrees with the Beck inventories and our inventories and the PAI and everything else. We have adjusted it for clinical purposes. So remember, our mapping system is built from bottom up for clinical purposes, and it's adjusted for that. Thatcher's is a purely research grade database, and he has not made the adjustments we have made, and we have disagreements about what clinicians should be getting, but that's healthy. Same thing with the other databases that are out there. Brain DX, they have their own concept on what a map should look like and what's clinically relevant, and it's different from mine or Thatcher's. And same thing with Sturm and Kaiser database. David Kaiser has a different perspective. He thinks we should be using a lot more measures. He's one called Alpha Unity, which he thinks is the most accurate measures, and none of us use that. So there are differences in these databases, and you use the one that you like, that works best for you, that makes the most sense for you based on your reading of the research. And that's just how things are today. Okay, so we think that this is the way to go. Now, if you're like, well, I don't want to use this, you can just click on Show Location Maps. It's right up there in the corner. So when you go up there and this pops up, you say, I'm not into this. Just click Show Location Maps and you'll get the old map. And it'll print it out. So you don't have to worry about that. So let's jump down to dominant frequency. And, a lot of this people, and especially the newer people, look at this thing like, I don't know how to make sense of this, And Martin will say, well, just look at it. Is this mostly blue? And people go like, I don't know, But Martin's been looking at this for 8 years, I think, or 9 years. And I've been looking at it longer, and Rob too. So we all look at that. It's like, oh yeah, there's more blue in there. But if you go down here, this mathematically on a scale tells you the percentage of blue. So now you can look down and say, well, here's blue. This is where it is. It's down here. So overall, this is more blue. Okay. Now there's a reason we didn't put percentage in here. And that's because the way this is calculated is not purely based on percent. And I don't want to go into the algorithms, but we spent a truckload of time talking, at least a half a year or longer talking this over and trying different models and algorithms. But this algorithm will give you an impression that's very similar to as if you were looking at this with 10 or 20 years of experience. You will see, okay, this is more on the slow side. Alpha dominant frequency, we're pretty dang slow here. Beta dominant frequency, we're getting faster. So you can look at it and say, okay, this is a pretty slow. Generally, this alpha dominant frequency is quite slow, and the overall dominant frequency is generally slow. Now, we may decide to add a metric here based on the algorithm, but it won't be until we have 6 months, a year of data from hundreds of clinics, and we can cross-validate it with other data that we have. And that's our commitment. And then you have interconnectivity sliders. And again, always the button in the top. You don't want it, just click on it and you get the old map view. It's very overwhelming for people to look at all of this connectivity and make sense of it. And there's been a large request for, can't we just get a general overview? Now, again, if you're Rob or Martin or some of the other people that have been looking at this for a long time, you can look at this and get like, oh yeah, Judy even. Say, yeah, I can see there's a lot of blue in the temporal region, suppressing emotions, not moderating them well, and declarative memory is going to be compromised at T3, T4 with beta issues here. And you could say, okay, P3, P4, O, and O2, we're going to have some problems with sensory integration. But you don't have to know it. That'll show up on the dashboard. If this shows up here, it shows up as sensory integration problems on the dashboard. If this shows up here, it'll show up on the dashboard, which we're going to simplify in the future too, this coming year. We kept all this stuff in here because we wanted to run the data and get people's feedback so we could make this jump to something simpler. We've been planning this for 8 years. So here we have the connectivity. So you can generally look at, well, are we generally in a more normal range, or is there a lot of hypoconnectivity? Are we in more of a hyperconnected range or less hyperconnectivity? And we'll be able to take this data and run values on it and see what it tells us. I don't know that this is going to give us a large general measure, but it might. I'm kind of into the weeds guy. This stuff is important to me. But for people starting out and have to explain it, this is a much nicer thing to show your clients and say, well, you're a little over hyperconnected. That brain is feeling a lot of stress, and it's hyper communicating. It's trying to manage something. So there's distress here. And that's a great statement right there. And when we train you and you get better, that's going to move towards the green because the brain's not going to be so distressed and communication is going to be more normal. Asymmetry sliders. I know a lot of people have a lot of problems making sense of asymmetry, saying, well, what percentage here and what percentage here? We actually have a percentage here because I actually ran numbers and published that on New Mind Journal and wrote it up. Once you're over 56%, people are going to start showing problems on the ISI and on the Beck inventories. So once that red gets up to 50, over 50%, our statistics show they're going to start reporting problems. Under 50%, they are going to be subclinical. They're just going to be typical nervous Nellies who are stressed. And that'll become more apparent to you. And I won't have so many people asking me, I think, with this slider in place. You know, these sliders are more what you would see on a lab test. You know, if you sent stuff out to Great Plains Labs or something, Genova Labs, this is the kind of slider. And so the other medical people and doctors and naturopaths and chiropractors who use neurofeedback, this helps them. They like this. This is what they want. So we have a lot of people who want this and are not interested in that drill down stuff. They're working with a simpler format. But here you can see the percentage, and I think people will get a much better sense of how symmetry relates to anxiety and depression and to their clients. And I think it'll help them understand the more detailed maps that you can drill down to. So the report output, if you click output report, it will give you both formats, and you can just choose which one you want to share with the client.